Hi, this is Mary from OpenHelix with this week's Tip of the Week. If you're seeing this tip someplace else, please be sure to come back by our blog at blog.openhelix.com for additional details. I'll provide links to the resource I'm talking about today, links to the publications, and so on, so check us out at blog.openhelix.com. For this week's Tip of the Week, I wanted to highlight the work in this paper that I really enjoyed last week. This group has generated an atlas of over 90,000 conserved non-coding sequences across a number of different plant species. And first of all, I think that plants are really great, and I think they're understudied, and I think it's terrific to have this kind of data available. But it's just such a great demonstration of once we have all these genome sequences available, what you can do. You can compare across these genomes to learn things about the biology that we didn't know before. This group has generated this atlas, and as I also mention a lot on our blog, the data from this paper, 90,000 conserved non-coding sequences, are not published in this paper. You cannot find them in the text of this paper. You are going to have to go to the software that's associated with this. And this group created an installation of the UCSC Genome Browser that holds all of this data. And so not only is it important to understand the literature, but you have to grasp how to use the tools that are associated with these data sets as well so that you can get the most out of them. Anyway, I thought this paper was really terrific. As I mentioned on the blog post, I really enjoyed the way they assessed the data here as shown in Figure 3. One of the points of this paper was that they could look at these regions that are under selection across these plant genomes. And of course the majority of this is the coding sequences, but there's some really interesting sections among these other regions of the genome that might provide insight into control and regulatory aspects that are really useful to understand now. So anyway, this is the kind of data that I thought was really interesting, and this is the kind of data that is summarized in the paper, but you really need to go to their Genome Browser installation to access the real data. So if you want to go to their Genome Browser, it's listed at the bottom of the page here. There's a link here to the browser that we're going to look at, which is an installation of the UCSC Genome Browser, which I will show you here. So here is the Vegi Database. I think that's great. So the Vegi Database here looks a little bit like a UCSC Genome Browser, as you can see, but what you'll have to do is click on here to find their specific data that's available for you. So the reference genome that they have set up as the default is the Lerata genome here, but you can choose to look at any of the species that are available, the Arabidopsis thaliana one or any of these other species too. I'll leave the default one, but you can go back later and try these others. And I'll also leave the default setting that they have here for this position, but you can search around the genome later. But let's just go to this position in the genome to give you a sense of the kind of data that's available here. What you'll find is that you have access to the genes and the comparison and these conserved non-coding sequences here. This was the really cool data from this paper that I wanted to look at in more detail, and that's available here. Now, one of the things when I first arrived, that was in dense mode, so I came here and turned it on to pack mode. But you can look at any of these, and you can change the menus here, and you can learn about how the data was generated from any of these pages, just like the regular UCSC Genome Browser. Another thing that I thought was useful was the gene prediction track that's available here is in dense mode, but I prefer to look at this maybe in full mode, refresh, because that will give me the direction of transcription, the arrowheads that you can see here. Now, if you're not used to using the UCSC Genome Browser, because it hasn't been as popular in plant genomes as some others, you might want to learn how to use the UCSC Genome Browser from our tutorial that we've got available that talks about how to understand these different kinds of regions. So not only is this great data available here, all of those conserved non-coding regions that are important from this paper, but the genome comparisons are really nice here. And another thing that's useful to me too, I was looking across just this region by default here, and of course there's mRNA data that corresponds to these gene predictions, which is great, but here's a case where there is no mRNA data, and I don't know whether this is a tissue or a temporal difference in the mRNA that was generated here, but also there's cases of mRNA that's available here, but there's no gene call. So there's even more interesting data available besides these conserved sequences that were the focus of this paper. Anyway, I encourage you to check out this paper. I think it was really well done, and you've got to come over to this UCSC Genome Browser installation to look further into the data and look more at the regulatory regions that are unearthed in these plants and start digging even further into this genome data. And you can use the table browser. This is a genome browser view as I've been showing, but the table browser is available too, and you can generate really cool queries. So check it out, this paper about the conserved sequences and the data that's available in their special genome browser they've set up. Thanks very much for your time.